Hey guys, it's Shahir from 5 Academy. Welcome back to another video. So today I'm going to be going through a series of intermediate difficulty ACT math problems. Problems that you're going to see in problem numbers like 20 to 45 on the math test. So the middle section of the exam, kind of where the test is growing in difficulty, okay? So these are very repetitive problems. You're going to see these type of things over and over and over again on the math exam. So knowing these problems, being able to understand how to get them right, knowing the methodology and the rules and the formulas behind them, kind of memorizing that is going to help you perform better on the math test. So, and again, you're not just trying to get these right, you're trying to get them right very quickly so you have time to save for the end of the exam. Okay. I recommend before I break each problem down, just try it yourself. See where you get to, see if you can get the methodology right yourself. If you get stuck at any step, then you can watch the actual clip or just watch the full breakdown. All right, let's get started. All right, for this skill. Composite functions. Which of the following is the composite function f of g of x of the two functions below? So this looks very confusing. What's this notation that's actually happening here? What you're doing is you're taking a function f of x where you have everything in terms of x's, right? And you're plugging in a whole new function, g of x, into each of those x's. So if I had f of x is equal to 3x, right? And I say y is equal to 4x, what I can do is say f at y is equal to 3 times, just plugging in y here and here, which is the same thing as plugging in 4x into here and also here, which is equal to, let me just rewrite it like this, right? It's equal to f at 4x, which is equal to 3 times 4x, which is equal to 12x. All right, just an example. Now let's apply that to a little more complex of a situation where there's more things going on in the function. So f of x is equal to 10x cubed minus x squared. So what I want to do, if I'm going to do f of g of x, let's first just clear everything out. Let's just do 10 of something cubed minus something squared. And this is going to be g of x inside of here. And the function, the problem tells you what g of x is equal to. So all we have to do is just plug it in, right? So f of g of x is equal to 10 times square root of 6 minus x cubed minus square root of 6 minus x all squared. That all equals to 10. Now, square root of 6 minus x can be written as 6 minus x all to the half. So let's just do that. 6 minus x to the half. All that is being raised to the third minus a square root being raised to the second is just going to give you the original thing, right? So that ends up giving you 10. Now, okay, you have 3 to the half. That's just going to give you, when you have an exponent to an exponent, you just multiply the two exponents together. 6 minus x to the 3 over 2 minus 6 plus x, aka plus 6 minus x, which is what the answer options kind of say. Okay, this is your answer. So again, it's a lot of simplification after this. That's kind of combining multiple skills together, like exponents and radicals and on top of composites, but same kind of methodology applies. So here again, just remember the basic formula of you're just plugging one function or one expression into all of the x's. So it's the simplest of this. All right, matrices. How do we do this? So matrix multiplication like this, problems like this, what you're doing is you have two matrices and you have to first verify that you can actually multiply those two matrices together. The way that you do that is you write out the row by column kind of layout of each. So rows by columns, the number of rows and the number of columns. The one on the left is obviously 2 by 2. The one on the right is a 3 by 2. In order for it actually to be possible to multiply two matrices together, these two numbers in the middle have to equal each other. And in this case, they do not. So your answer is going to be E. But let's say they were. Let's say you're multiplying, let's just say 1, 2, 3, 4 by 4, 3, 2, 1. Okay, the way you do it is you'd multiply across and down, across and down, across and down, across and down. Okay, so again, it seems kind of confusing, but before I even jump to that, right? If I do my row by column layout, the two numbers in the middle are equal, and what happens is the two numbers on the outside actually tell you the dimensions of your final matrix, your final answer. So my final answer is going to be a 2 by 2, 2 by 2, okay? 2 for rows, 2 for columns. So in this case, Now, how do you actually arrive at that answer? What does that look like? You do the multiplication kind of like I laid out earlier. You multiply each row item by each column element, okay? So each row element by each column element, and you add as you kind of march across your rows or march down your columns. So the way that's going to look is this first element right here. I'll just bring it down, do it here. It's going to be 1 times 4 plus 2 times 2. That's going to go in my top left. Okay. That's my first element. Okay, so you see how I went across and down. Now my next is going to be, if I want to get this top right element of my answer, it's going to be 1 times 3 plus 2 times 1. Again, right? What did I do? I went across and down. Now again, let's go to the bottom left. In order to get the bottom left, I literally have to multiply the bottom and the left. If I want to get the top right, I have to do the top by the right. So you see how everything kind of corresponds now. It's kind of adding up together, right? Literally. So it's going to be 3 times 4 plus 4 times 2. You go right and down, across and down. Okay, so 3 times 4 plus 4 times 2. All right, and then the final one, bottom right, 3 times 3 plus 4 times 1. And I'm not even going to evaluate the rest of this. This is just a hypothetical scenario. You can go ahead and add these together. What I recommend is if you're having a hard time with matrices, just make up a bunch of matrices, see if you can kind of play around with different dimensions, notice patterns, make up 10 different matrices problems for yourself, solve all of them, use like an online calculator to check your answers, and see where you get to. That'll help you a lot, just get better and better at this. Okay, that's for matrix multiplication. Now, what about matrix addition and subtraction? In order to add and subtract matrices, the two matrices, or 3 or whatever it is, have to have the same dimensions. So 2 by 2, 2 by 2, it's equal, so you can add or subtract across. The way you do this is kind of intuitive. You just multiply add or subtract corresponding elements with each other. So 6 minus 2, 7 minus 7, 3 minus 11, 1 minus 5. So it's going to give you an answer of 4, 0, negative 8, negative 4. 4, 0, negative 8, negative 4. Substituting into polynomials, this is a very simple skill, but it's easy to make sign mistakes on these problems. And you see it makes up a good amount of the exam, about 5%. It's going to show up every single time in around problem 20. So what you do is you're going to be given a function like this. You're going to be asked, hey, what is h of 1 or h of negative 1? What this means is you're taking all of your x's, including the one here, right? That's why they're writing h of negative 1. And you're going to be plugging in negative 1 into each of them, or whatever number they give you. Kind of like what we did with f of g of x above, but instead of plugging a formula into a formula, you're plugging a number into a formula and arriving at a number answer. Okay, so how do we do this? So h of negative 1, I'm going to have 4 times what used to be x squared minus 16 times x minus 4. And I recommend you write it out this way. Write it out kind of spread out so you can go ahead and erase the x's, plug in negative 1s, and notice how I did this in parentheses, just to separate everything out from the rest of the stuff in the equation. And then you go ahead, once you did your replacement of x's with your negative 1 or whatever number it is, you go ahead and simplify. So 4 times what's negative 1 squared, which is 1, right? Negative 1 times negative 1. Minus 16 times negative 1, well, I can really just evaluate that, right? It's minus 16 times negative 1. If I just do it like this, 16 times negative 1 is negative 16. Minus 1. Just do it one more time. 4 times 1 is 4. Minus negative 16 is plus 16. Minus 1 is going to give you 20 minus 1, 19. Now, it looks like I did something wrong. And I believe... Oh, this is a minus 4. Apologies. So your answer is actually going to be 16. All right, next problem type, finding patterns in sequences. Convert the following geometric recursive sequence to an explicit geometric sequence. So what's a recursive versus an explicit geometric sequence? A recursive is basically when they write the next term as a function of the previous term, whereas an explicit is where they write the next term as a function of the first term and the common ratio. So an example is most geometric sequences that you've seen have been in the form a of r is equal to a of 1 times r to the n minus 1. This is explicit because it's a function of a1 and r, and also n, but mainly a1 and r. Now, if they give you it's supposed to be a of n. If they give you a of n is equal to a of n minus 1 times r, this is recursive because it's purely a function of r and the previous term. Okay, so here it's kind of in this form where really this is n plus 1 and n, same idea, right? They're giving it to you in the form like this, and they're telling you what a1 is. So the way that you're going to go ahead and convert it to an explicit is you're just going to, again, what do you need for an explicit? You need to know two things. a1, you need to know r. We already know a1, and we know that, like what I just showed you, a of n is equal to r times a of n. We know a1, we know r, which is just 10 times, it's just 10. So you can actually find the explicit geometric sequence. A of n is equal to a of 1, which is 3, times r to the n minus 1. Simple as that. You just got to know what each is and convert. Systems of equations. Okay, Biking Team A charges its team members $3 per month for membership plus $3 membership fee. Biking Team Z charges $2 per month for membership plus a $10 membership fee. After how many months is the price of Biking Team Z's membership twice of that of Biking Team A? Okay, so I'm going to make, it's probably a good idea to make an equation out of each of these. There's two ways to solve it. You can make an equation or you can make a table. So if I was to make a table of charges, so let's do this. It's really going to be a three-way table. And this is not the best way to solve it, but I'm just going to visualize it just to help you kind of learn the process. So let's say months, right? We're going to say, and then cost of A and cost of Z. Okay, so we're going to have 0, 1, 2, 3, 4, 5, 6, 7. Okay, now the cost of A at month 1, right, what are you paying? $3 per month for membership plus a $3 membership fee. So really it's going to be 6 for the first month, and then every month after that you're just adding 3, right? 24, okay. Now for Z it says $2 per month plus $10 membership fee. So your first month is 12, then you're going 14, 16, 18, 20, 22, 24. Ah, look at that. I got the answer just by writing it all out. So if you look at a problem like this and you're really not sure, you can table it out and go up until really the values it tells you to, and you should end up at your answer. But let's say it's a case where the numbers are way too far out and tabling it is just not possible. You're going to need to make a formula out of these. So when you see constant rates and when you see a cost or something that's made up of a constant rate and a base value, your y equals mx plus b formula is going to be your best friend, where m is the rate and b is the base value. In this case, your base value is your fee, your membership fee, and your rate is your monthly fee. Right? There's a base fee of $3 plus a monthly fee of $3. So your function for cost, I'll say CZ, right, is going to be, well, let's just say cost of Z is going to equal to, and I'm going to compare it to cost of A. Cost of A is equal to, A is $3 per month plus $3 membership fee, so let's just say 3x plus 3, where x is the number of months. And Z is going to be $2 per month plus $10 membership. And you're trying to find when the costs are going to be the same. What you actually are going to be doing is make 2x plus 10 equal to 3x plus 3 and find at what value of x do they line up. If you solve this equation, so just do negative 2x, 10 is equal to x plus 3 minus 3, x is equal to 7, you get the same answer. Okay, I showed you two ways to solve systems of equations. All right, solving and graphing inequalities. Which of the following is the graph of this? So graphing inequalities like this, if you're given it in this form, I recommend you break it out into two inequalities. So really this is 2 and 1, right? And that's why you see two different graphs kind of in one here, almost. So it's really negative 3 is less than x, and then x is less than 5. And remember, you might remember in elementary school, like the crocodile rule. So if you have x is less than something, the arrow is going to be pointing this way because the crocodile sign is pointing that way, or the arrow is pointing that way. But here, you think, okay, maybe it's going to be pointing this way as well, but it's actually not because this is written in reverse. You have to have it written in order to follow the crocodile sign rule. You have to have it written in the form where x is first, and then you write greater than or less than, and then the number. So in this case, it's saying -3 is less than x, aka x is less than -3, if you look at it in that way. So it's x is less than -3. Sorry, x is greater than -3, my bad. X is greater than -3. So you're going to have one arrow from -3, and they're both going to be hollow circles, right? No solid circles. You're going to have one arrow at -3 pointing to the right, just like this. And you're going to have one arrow at +5 pointing to the left. And so anything in between is shaded. That's really what you're interested in. So answer option E is your answer. Another problem, similar to like the one I did before, but here you're actually solving the inequality using, because there's an unknown value here, you're going to solve for x. So the way we do this is you treat it as if there's 3 sides to the problem. So I'm going to do, the whole point is to isolate x and get it to a form that looks somewhat like this. I'm going to do that by subtracting 12 on both, or all 3 sides. I end up with -30 is less than -6x is less than or equal to -18. Divide everything by -6, right? Again, we're trying to isolate x. And again, remember, when you multiply or divide an inequality by a negative number, you end up switching the directions of the signs. So you're going to think, okay, the answer is -30 divided by -6, which is 5, is less than x is less than or equal to 3, right? But you're going to have to flip all the signs, because that's what multiplying or dividing by a negative number does to inequalities. So now you have 5 is greater than x is greater than or equal to 3, which I would rewrite as, again, it's saying 3 is less than or equal to x is less than 5. Okay, and that is your answer right here. All right, this problem type, complex numbers. This can show up in a variety of ways. I've chosen a very hard example here. So this is where you're asked, hey, I have this weird thing here, and I want to simplify it. Which of the following is equal to this? So what you're going to do here in order to solve this and identify what is equal to 1 over 3i minus 4 is you're going to multiply this by a fraction. This fraction is going to be equal to 1, which is going to be like something like this. It's going to be something divided by itself, but it'll help us simplify this to bring this to a form that looks something like the answer options. Now what that fraction is going to be is when you're given an expression ai plus b, where I is just square root of -1, right? It's an imaginary number. You can actually find a complex conjugate of that. So every I expression is actually in pairs, think of it, right? It has a complex conjugate pair known as just the same number, but you switch the sign of the term that is not the I term. So in this case, you'd have 3i minus 4 and then 3i plus 4. What you're going to do with this complex conjugate is you're going to multiply, you're going to put it into the numerator and denominator of this fraction, and you're going to multiply across. End up with 3i plus 4 divided by, so 3i times 3i, 3i times 4, -4i times -4 times 3i, and -4 times +4. So that gives me 3i squared plus 12i minus 12i minus 16. 3i plus 4 over, so what's 3i squared? That equals 3 squared times I squared. 9 times -1, -9. -9 plus 12i minus 12i is 0, minus 16. That gives me 3i plus 4 over -25. And I can go ahead and simplify that a little further. -3 over 25i minus 4 over 25. Okay, that's it. That's how you do it. And you end up with this answer right here. So again, remember, if you're given an expression like this, take your denominator, switch the sign of the non-I term, make a fraction out of it, and multiply this entire thing by a fraction of that complex conjugate divided by itself, and just multiply across. Do your foiling like we did here, right? I did 3i minus 4 times 3i plus 4. I get a whole number as my denominator, and I end up with a form that's actually workable. So that's all I have for this video. Hopefully this was helpful. If you have any questions, let us know in the comments below or leave a message on our website. We have more problems just like this. And actually these problems are directly from our website. We have lots of problems devoted to each individual skill. So if you're having trouble with math skills, concepts just seeming very foreign to you, or you learned them like 2-3 years ago and you forgot them, check out our website. It's actually a very useful resource that a lot of students have used and have had very quick success with in terms of developing skills, learning them quickly, and implementing them on their actual tests and improving very fast. So definitely, if you have any questions about it, let us know. We're here to help. Whether you join our paid courses, free courses, we want to make sure you get as much help out of our website as possible. We also have on our website free tutoring. Yes, I did say free tutoring. You can schedule one free 15-minute tutoring session with myself or one of our experts just using the link down below. All right, best of luck on the exam, and hopefully this was helpful. See ya.